Imagine a force of nature so powerful, so completely wild, that it actually breaks its own rules. Think about a wildfire that seems to move directly against the wind. No, this is not science fiction. This is the incredible and frankly terrifying story of the Los Angeles fire of 2025.
So picture this. It's just after 11 in the morning. A man named David Murrow is out on his apartment balcony, just enjoying the view of the Pacific Ocean. It's a totally normal day. Until he sees it. About 5 miles away, up in the hills of the Pacific Palisades, he spots the very first sparks of a fire. And within just a single hour, that little spark becomes an absolute monster, a wall of smoke so thick it completely swallows the mountain.
Now, on that particular day, the winds were just ferocious, gusting up to 100 kilometers per hour. And their direction? Well, that was unmistakable. They were blowing from the inland deserts straight out towards the ocean. A powerful, relentless offshore wind. No question about it.
And right there, that's our central mystery. The fire started near the coast, the incredibly strong winds were blowing towards the coast. So how on earth did this inferno travel 40 kilometers in the complete opposite direction, marching inland against what was basically a hurricane-force headwind? That is the puzzle we are going to solve together.
To find the very first clue, investigators didn't look at the fire itself. Nope. Instead, they looked at the calendar, because they were searching for a pattern. And what they found was, well, it was chilling. Just take a look at this timeline of some of California's most destructive wildfires. You've got the Cedar Fire back in '03, the Camp Fire in 2018, and now this one. Do you see the common thread here? Look at the months. They all happen in the fall and winter. We're talking September, October, November, December, January, not in the blazing heat of summer. So you have to ask, right? What is it about this specific time of year in California that creates such a perfect storm for total destruction? Well, the answer lies in a legendary and pretty notorious weather phenomenon.
Okay, let's talk about the prime suspect, the main force responsible for California's intense fire season, the infamous Santa Ana winds.
For anyone who's not familiar, the Santa Anas are seasonal winds. But trust me, they are not your average breeze. They are scorching hot, they are dangerously dry, and they just howl through the canyons with unbelievable force, specifically during the fall and winter.
So, how do they even form? Well, it's actually pretty basic physics, a classic showdown of air pressure. To the east of California, you've got the huge hot Mojave Desert. This creates this big dome of high-pressure air. And then to the west, you have the cool Pacific Ocean, which creates a zone of low-pressure air.
Now, it's a fundamental rule of our atmosphere. Air always moves from high pressure to low pressure. So that hot, dry desert air just comes rushing towards the coast. And as it barrels across the landscape, it acts like a giant hairdryer, sucking every last drop of moisture out of the trees, the brush, the grass, turning the entire region into a tinderbox, just waiting for a spark.
Okay, so this all makes sense, right? The Santa Anas perfectly explained why these fires happen in the winter and why they get so incredibly intense. But here's the thing. This only makes our central mystery even deeper. Because remember, the Santa Anas blow from the land out to the sea. This fire did the exact opposite. Something else had to be going on.
And this is where our whole investigation takes a really fascinating turn. The solution to the mystery wasn't in the wind itself, but in how the wind was interacting with the landscape. It was a mountain's secret weapon.
The phenomenon is called a mountain wave rotor. I know, it sounds super complex, but the idea is actually pretty simple. It's all about what happens when a powerful, steady wind flows over a tall mountain range. It creates this bizarre, completely counterintuitive effect on the other side. So let's break this down. First up, you have the windward side of the mountain. This is a side that's facing the oncoming wind. And here, the air flows exactly like you'd expect. It hits the mountain and just flows smoothly up and over the peak. Pretty straightforward, no surprises here.
But now for the crucial part. On the other side, what we call the leeward side, the air flowing over the top creates this sort of vacuum effect below it. This triggers a spinning vortex of air, a rotor. And just look at the direction of the wind at the bottom of that vortex. It's blowing in the complete opposite direction of the main wind that's flowing high overhead.
And there it is. That's our solution. The Pacific Palisades, where the fire started, was on the leeward side of the mountains. So while the powerful Santa Ana winds were roaring towards the ocean way up high, this mountain wave rotor created a localized, powerful reverse wind right at ground level. And that's what grabbed the flames and pushed them inland completely against all logic.
So the mystery is solved. But when a fire gets pushed by this kind of paradoxical force, it grows to a scale that is, well, it's almost unimaginable. It becomes so powerful, it literally starts creating its own weather.
Let's just pause for a second and absorb the sheer scale of this disaster. 38,000 acres burned. I mean, that's an area of over 150 square kilometers. More than 12,000 homes and other buildings completely destroyed. And 180,000 people were forced to flee their homes. This became the single most destructive fire in the history of Los Angeles.
A fire this intense can spawn one of nature's most terrifying and rarest phenomena, a fire tornado. And yeah, it is exactly what it sounds like. We're not talking about a tornado that catches on fire, we're talking about a fire that becomes a tornado. Here's how it happens. The unbelievable heat from the wildfire creates this violent updraft, just pulling air straight up. And to fill that void, cooler air from all sides rushes in. This massive collision of air currents, all being pulled by that intense heat, starts to rotate, creating a spinning vortex of flame, ash, and debris that is just utterly devastating.
So, when you combine these bizarre wind mechanics with fire that literally generates its own weather, you're left with a pretty terrifying verdict about our relationship with the natural world. You know, this isn't a new lesson. The first recorded megafire in American history was the Peshtigo Fire, way back in 1871, which burned 1.2 million acres. From then, all the way until now, nature has been sending us a very consistent message. When its forces align, it is nearly unstoppable.
We've explained how a fire can defy the wind, but it really leaves us with a much bigger question. In a world with a changing climate, where these events might become more frequent and even more intense, is our greatest challenge really trying to fight these forces head-on, or is it learning how to understand them, and maybe how to adapt to them?